Today we are going to review how to get ready for graphing. We're going to start with manipulating or changing equations, which is what we did in the equations standard chapter that we worked on a couple weeks ago. And then we're going to actually graph using T-charts. So I'm going to do a couple examples from your practice work packet, and then you guys will be able to finish it on your own. So this first page of the packet talks about solving each equation for y. We basically want to get y by itself. We're solving for y, so we need to make sure that y is alone. We're going to, if you remember, put these equations, which are actually in standard form for graphing, and put them in slope-intercept form. If you don't remember that, don't worry, we'll get back to that later. But basically, we want y to be by himself. I'm going to do the first 3 examples with you, and then you guys can do the rest, the last 9. So for the first example, I have y that needs to be by himself. The first thing I need to do when I draw my line is get rid of the 2x. Because 2x is positive, I subtract it over so that it cancels out. When I do that, I am left with 3y, a positive 3y on the left of the equation. This is what I want you to do for this worksheet. Do not write 6 minus 2x. I want the x to go first. So we write minus 2x plus 6. 0x is minus 2x, so that becomes a negative 2x, and 6 was positive, so we just changed the order. It will help us put this into slope-intercept form later. Now y is not by himself yet, so the last thing I have to do is divide. I need to divide by 3 to every single term on this equation. When I do that, I am left with y, and you guys are going to keep your fractions. So negative 2 divided by 3 is negative 2/3 x, and then 6 divided by 3 is a positive 2. This is your answer that I am looking for. I want to see fractions that are simplified. I do not want to see decimals. And I want to make sure that the x value goes first. So if you remember, this is slope-intercept form of y equals mx plus b. Again, if you don't remember it, don't worry. We will review. The next example is very much the same. We need to get y by himself again, so the first thing I need to move is the x. I am always moving the x value first. Because x is positive, I subtract to make it gone, so 1x minus 1x, and I subtract on the other side. I am left with a negative 4y equals minus x plus 8. A couple things to look at here. Please make sure that the minus 4y becomes a negative 4y. You need that subtraction sign to stay there. When you subtract x to the other side, I want it first. So I put it first on the right side of my equation, and it's negative. The 8 was positive. The last thing we do to get y by himself is to get that negative 4 out of there by dividing. So you divide everything by negative 4. What we end up with is a negative 1 over negative 4x minus 2. Now let me explain. When we have this negative x, there's really 1 there. So we have the fraction of negative 1 over negative 4. Then we have 8 divided by negative 4. Well, that becomes negative 2. I can go ahead and simplify this even more because a negative minus a negative is a positive. So we have 1/4 x minus 2. You will be seeing a lot of fractions here today, guys. The last example I'm going to do is this third one. Again, the same situation where I need to move x to the other side. It's a positive 8, so I subtract it to the other side. I am left with negative 3y on the left, then negative 8x minus 6. I keep putting that x first. Now it's a minus 6 this time because 6 was negative. To get rid of the negative 3, again I divide by everything. And it is a negative number. So I'm left with a negative 8 over negative 3x. And then it's a plus 2 because negative 6 divided by negative 3 is a positive 2. Now I need to simplify that final fraction because a negative divided by a negative is a positive 8 over 3x plus 2. You may keep your answers as improper fractions, but if you can reduce some, that'd be great. On this example, you can't. So basically for all of the rest of these examples, you're going to move x to the other side either by adding or subtracting, then dividing by the number that is attached to y. On this fifth example, I want to show you guys, we have a minus y. Make sure you that it's a -1 there because you'll have to divide by him. Keep all of your equations as your answers in lowest form. On the next page of your practice work packet, we're going to start graphing different linear equations. These, for the most part, are in linear or slope-intercept form. Some of them are in standard form, but again, if you don't remember them, that's fine. I'm actually wanting you guys to do a t-chart to help find the points of your graph. Whenever you guys have a coordinate, the coordinate is actually x comma y, meaning you go along the x-axis horizontally and then go up the y-axis vertically, or you can go down or to the left. So when we have a number plugged in for x into our equation, we'll get an output of y, and that'll give us our coordinate. So the first thing you have to do is make sure you figure out about 3 numbers that you can plug in to your equation and plug in for x, and then you can graph your points. So what I'm going to do is I'm going to choose -2, 0, and +2. I would try and stay pretty small with your numbers, but 0 is always a good one to plug in because it's pretty easy. So if I'm plugging -2 into this equation for x, I get y equals 2 times -2 minus 4. We go ahead and solve that, so I get -4 minus 4, and then when we solve that, we get -8. So our very first coordinate is actually -2, comma, -8. So on our graph, we go ahead and graph that. We go to the left 2 and down to -8, and we plot our point. Now we plug in 0. So we have y equals 2 times 0 minus 4, and 2 times 0 is 0, so we have 0 minus 4, which is -4. So again, another coordinate that we're going to graph. You go left to right 0, and then down 4, and you plot your point. We go ahead and finish this by plugging in 2 to our equation. So when we do that, 2 times 2 is 4, and 4 minus 4 is 0. So our final coordinate that we have is 2 to the right and 0 up and down. As you should see, this makes a straight line, and we just draw a line through it to connect the dots. Let's see how this goes. Whoops. I'm just going to draw it like that. Please try to be as straight as possible. If you need to use a ruler, you may. And that is what the graph would look like. The next example is a little harder because it does have a fraction. Now, I did want to show you guys that instead of 2 equal signs, this should be a -2 and not an equal to. Typo. All right, so when I have this fraction of -3/4, I'm going to be multiplying it by whatever number we plug in. So I like to do any multiple of our denominator because our answer then will not be a decimal or a fraction. It's going to be easier to graph. So what I decided to do is, because our denominator is 4, I just picked a -4 and a +4, and like I said earlier, 0 is very easy to plug in. So I go ahead and start with our first problem in our t-chart. So we have -3/4 times -4, and then we're going to subtract 2. When you do that, to multiply our fractions, we have -3/4 times -4/1, and we go across, which is +12/4 minus 2. Now, 12/4 is the same thing as 3 because it's 12 divided by 4. So 3 minus 2 is 1, and that is what we get for our first coordinate. So we go to the left -4, and we go up 1. When we plug in 0, we have y equals -3/4 times 0 minus 2. So we get 0 minus 2 because that fraction times 0 is 0. And 0 minus 2 is -2. So when you plug in 0, you go to -2, which is this point. The last one, is a positive 4 this time. So we have a negative 3/4 times 4 minus 2. So just like we did earlier, we have negative 3/4 times 4/1, and you multiply across, which is negative 12/4. That's also the same thing as negative 12 divided by 4. So we have the answer of negative 3, and then we bring down this negative 2 or minus 2. Our answer becomes negative 5. So that's our next coordinate that we plot. We go to the right 4 and go down to 5. When we do that, we see that we have a straight line that we draw and connect the dots. Please remember, if you have a fraction in your equation, to plug in numbers that are multiples of the denominator. So if you have a denominator of 3, then you can choose negative 3 and positive 3. You can choose 6, negative 6. It will make sure that you won't have a fraction as your answer. On the last page of our packet, the only thing you have to do is plug in the numbers given in your t-charts. So previously we had to come up with our own t-charts and our own values for x, but this time we just have to graph using the ones given. So you just have to plug in what you know. I'm just going to plug in a couple from our first example, and then you guys can finish it up and graph it yourselves. But we have a negative, or y equals negative x. So what you do is you plug in your first value. So y equals a negative 7. Now this means a negative 1 times a negative 7, which is positive 7. So our value becomes 7. You go to negative 7 to graph, and then you go up 7, and that's your first point. All you have to do is plug them in and then draw your line. Go ahead and finish the entire packet and check your answers with your neighbors.